Hey guys, it's Christian, and in this video I want to talk about how you can easily migrate your services and applications from simple Docker Compose stacks to Kubernetes deployments without rewriting everything from scratch. Now, we all know that Docker and Docker Compose are truly amazing. I mean, I'm using this in nearly 90% of all of my video tutorials because Docker Compose is easy to understand, and if you want to follow along, you just install the Docker engine on your workstation or server, then copy my Compose template, and it probably works in 99% of all the cases. But as great as Docker is for deploying production-ready applications and services, it isn't often the preferred choice because in a production system, you usually want to have an auto-scalable platform with advanced features. So as an IT guy or developer, you often have that situation that you're using Docker or Docker Compose for testing stuff locally, but when you want to move that to production, you often have that challenge to turn this into a real production-ready Kubernetes deployment. But don't worry, I've recently discovered a tool that is called Kompose, so not with a C but with a K for Kubernetes, that promises to simply convert Docker Compose files into Kubernetes deployments immediately with just one single command. Honestly, that sounds too good to be true, so in this video we want to check out how good it really is, and of course in which use cases this tool is really good, but in some others you might use a different tool, something like a sophisticated package manager for Kubernetes called Helm. But before we dive into these two, I also quickly want to talk about how to actually manage Kubernetes in production, because once you've migrated your applications and services to Kubernetes, you will quickly realize that managing clusters at scale can become quite complex. And that's exactly where Plural comes in, the sponsor of today's video. Plural is an AI-native Kubernetes management platform at enterprise scale. So what makes Plural so interesting? Well, first of all, it has a really nice Kubernetes dashboard where you can manage all of your resources with ease, but it's of course just more than a simple dashboard. It has a robust and powerful GitOps workflow that spawns Kubernetes, Terraform, Ansible, and other infrastructure as code tools fully integrated in your Kubernetes cluster, all defined as code, and it supports drift detection and changes on Git push. You could also set up global services and deploy them across multiple clusters. For things like traffic or cert manager, you usually want to always have on Kubernetes. And another feature that I find particularly exciting is the intelligent upgrade automation, which spots risks by automatically detecting API, CRD, and add-on incompatibilities before an upgrade. And honestly, guys, this is huge because Kubernetes upgrades can be scary, and Plural takes a lot of that risk away. Then there's also a really smart AI-based troubleshooting feature that can help you to detect anomalies and misconfigurations across Terraform, Kubernetes API, and cluster metadata. And the best part, Plural works with GCP, AWS, Azure, but also any edge clusters like my HomeLake K3s cluster, for example, as well. And you can easily get started with a free 30 days trial. After that, it's starting at $450 per month, which I know is quite a lot for smaller environments. However, I've also talked about this to the guys at Plural. They are currently working on a cheaper home or student license that we could in the future use for our home labs as well. So definitely check out Plural using the link in the description box down below and start with a free 30 days trial. Then just talk to the Plural team. They are really helpful and responsive. Okay guys, so now let's get started with Kompose, a simple conversion tool for Docker Compose stacks to container orchestrators such as Kubernetes, but it's also supporting OpenShift, by the way. You can really easily install this on your Linux, macOS, or Windows workstation. So just run these one-line commands depending on what installation method you prefer. On macOS, you usually want to use Homebrew, of course, and then you can just run the compose command in your terminal. As you can see here, as a parameter, you just put in your Docker Compose stack and type in the command convert, so this converts it into real Kubernetes manifests. Actually, that's already the whole magic behind it, so there is no real complexity. So that's why I thought let's just run through a simple demo example. So here in this folder, I've created a simple Docker Compose file that deploys a simple Nginx web server. So it's a really simple Compose file, but just know that you, of course, can also have multiple services, even with databases. And you can also have volumes, you can have port exposures that will automatically generate service objects with all the related port numbers and basically everything you will need. There are a few special things that are probably not working the same way in Kubernetes as they are in Docker Compose. So don't expect it to port any traffic labels and automatically move that into an ingress object or something like this. It's just converting these Docker Compose labels into Kubernetes metadata with annotations. But anyways, I think if you're working with Kubernetes already, you know that this, of course, is not a simple one-to-one conversion. But again, let's just run this in the terminal and see what it comes up with. So here again, we have the compose file, and then we simply just type in compose. You can put in the compose file as an input if you want, but it's optional. It will automatically detect the compose.yaml file in the current folder. By the way, there are also some arguments that might be useful. For example, if you want to switch from Kubernetes provider to OpenShift, there is a provider flag. Or if you want to automatically attach a namespace, there's -n for that. The one thing that I want is I want to put the output manifest into a separate folder because I don't want to have that in the main directory. And I also want to attach this to the namespace nginx1. Alright, so let's type it and enter. And yeah, as you can see, there's successfully created 5 different files here. There's just one small warning here that the restart policy unless stopped in the service web is not supported because this is not existing in Kubernetes. So it will convert it to always. If you're not sure about these conversions, there's also a compatibility matrix. There you can see what are the supported versions for Docker Compose and what that might be converted into. If any commands will be converted to container arguments. If you're using a compose file for deploying stuff to Docker Swarm and you want to turn this into Kubernetes, here, for example, you can see that the placement argument, so that usually defines on which Swarm node that stack would be deployed, will be translated into Affinity. And yeah, some other stuff, you can just go through the table if you're searching for a specific attribute. But yeah, again, let's take a look at these files that are created. So here in this directory, you can see there's a namespace manifest created because I've defined that in the command. There's a deployment that has been generated. As I said, these traffic labels are not automatically translated into ingress objects. They are instead just added as simple annotations. So maybe that might need some post customization from your side. So in this example, I would just remove these here and maybe create another ingress route object myself. But at least I don't have to create all the complicated deployment manifest. Yeah, you can see it's creating all the important stuff like the specifications for the containers with the right image, the name, the container port. You can also see that the container port here is 80, but there's also a service object that has been generated to expose this on port 8082. By the way, these annotations here are automatically added by the Compose tool. You can remove them, but you can also leave them here. That is mostly just for that you know where these objects were originally coming from. But yeah, that depends on your preference if you want to remove this or not. And what is also interesting, let's go quickly back to the Compose file. So here you can see for my Nginx server, I added 2 volumes here. The first one is a mount from the default.configuration into the container's default config path if you want to customize any of these server configurations or the internal port, the server name, whatever. And here in the data directory, there's a simple index.html file. That is a super simple template, so nothing in here. But usually you would put your application or your website code, whatever you want to publish in this data directory. And here, this compose file has generated 2 config maps here. First one is for the default.conf file, and the second one is for the index.html file. So that contains all the HTML code. Actually, this is probably something that I would want to change because I would want to switch that to use a real volume, maybe with a persistent volume claim. But for a simple test, I think this is totally fine. Let's deploy this to my test environment. So I just need to run kubectl apply and specify the Kubernetes directory where all the manifest files are in there, and it will automatically just create the Kubernetes resources from all these files automatically. So let's first of all check if the pod was created. Yes, this is already running. Everything that is in the namespace, the service object is there, the deployment, the replica set, so everything should be up and running. Now, as I can see, this is my local test environment. I'm using OrbStack for that, so that can simply run Kubernetes pods and services, but also containers, virtual machines. It's really great. I've made a separate video about OrbStack. It's really amazing. When you just go to the services here, you see the web service for the Nginx deployment. There's also a simple domain or a cluster IP address that we could use. So I can just copy this, put it into a new browser window, and that is my simple Nginx web application, or yeah, the web server. That's really simple. You can very easily convert a Kompose stack in just a minute or maybe even less into a Kubernetes deployment, creating all these files with the ports, with the config maps, the deployments, the services, so you don't have to mess around with this yourself, and super quick and super simple. But you probably already noticed that the solution or the conversion with the config map for a web application that might contain more than a simple index.html file, it's not really the best tool for production-ready applications. So therefore, I think Kompose is great when you have your own custom applications, microservices. It's also great for quick migration of existing Kompose files and stacks or prototyping. So you just want to see how and if that's actually working in Kubernetes, or maybe for niche internal tools without any published Helm charts. But of course, there are a few challenges with Kompose. It has limited support for advanced Kompose features. The generated manifests are very basic. You need manual tweaking for production, just like we talked about. The traffic labels. Volume handling can be tricky, as we have seen with the config maps. Also, the generated YAML files might not follow Kubernetes best practices without modifications. What do I mean by this? So here, for example, the deployment uses a simple service object, but for a production-ready application, I probably would use different best practices with using a real reverse proxy, maybe with integrating Cert Manager to have trusted TLS certificates and all of that stuff. So that, of course, Kompose usually does not do for you. So therefore, I think it is better to use Helm charts, especially for third-party applications, because they usually come with production-ready configurations. They usually, or most of the time, should follow the best practices and are maintained by their communities or developers. And they often have extensive config options with variables tested by the community, have regular updates, security patches, and complex features built in. So that might include HA backups, monitoring, like the metrics endpoint and stuff like that. So if you're not familiar with Helm, I've made a tutorial a while ago about this, but this is an advanced package manager for Kubernetes. So as they say, it is the best way to find, share, and use software built for Kubernetes. So yeah, what else would you say about your own application? Yeah, but anyways, it's really great. The new version 4.00 was just released for Helm, so there are a few new features. I don't want to go through these because I think it's not so interesting, mostly for developer stuff. But if you're searching for any Helm charts, for example, an Nginx web server, then you can also find these charts on the artifact hub, so there you can search for something. There are a few different charts maintained by different developers or communities. I personally like the Bitnami charts the most. When you go to the templates, you can see that this Helm chart already creates all these objects like config maps, deployments, like all these manifests, but they have a sophisticated templating engine. As you can see, there are a lot of if-else statements. So depending on what values you give this tool, it will generate the manifests in a specific way that is tested, that is audited and maintained by the developers or the creators of the Helm chart. So that might also include specific objects for reverse proxies, like here, for example, is an ingress object that could be picked up by the Nginx or traffic reverse proxy. Here is a TLS secret for the certificates. So there is a lot of this stuff that you would have to customize otherwise when you're converting with a Kompose tool that is automatically handled here already. So if you want to simply deploy an Nginx web server on Kubernetes, you can convert your old Kompose files if you want, but actually it is, in my opinion, still better to use Helm charts for this. First of all, you have to install the Helm tool, of course, so just go to the documentation. There's a simple script that you can just copy and paste in your terminal. There's also a homebrew package manager for macOS. There's Chocolatey for Windows, Scoop, Winget, and apt for Debian Ubuntu, and a DNF yum package for Fedora, snap packages. So there are many different ways how to install this thing. Just copy the one-line command in your terminal, then you can just use the Helm command, and then just go to the chart that you want to install. So here, for example, it's also a simple button on the Bitnami Nginx chart, how to add the repository. And then you have to run Helm repo update to update the latest version for all the chart repositories that you have added to your workstation. And then you can just run a simple Helm install. So that will install the Helm chart and generate all the manifests automatically for you. Now, if you want to customize a few specific things here, you should also, before doing this, take a look at the README file. Here are some configuration and installation details described, such as how you add resource limits and requests, how to enable Prometheus metrics, how to secure traffic using TLS, and also how to deploy your custom web application. This is probably the most important section here, because with the Kompose tool, as you might remember, we just used a simple config map for this. Here, this actually supports cloning from a Git repository, so you can just enable these values here, put in the URL of your Git repo where you have your application or website code, and then just deploy it from there. You can also add custom server blocks, so you actually don't need the config map for default.conf. This is automatically handled by Helm for Nginx. This is, of course, much, much simpler. Now, you might wonder how to set all these variables. Well, you can just add them in the Helm install command using the set command. So set and then the variable equal the value, but you can also create a simple values file. So that, in my opinion, makes the most sense, because then you can just define the values and review them before you actually execute the command. It is a good idea to just go to the default values, so that will give you the structure and the hierarchy of all the values and how they are defined. Basically, you could just copy everything in here, paste it in, and then customize the sections that you want. Or you could just get rid of everything and just add the variables that you want to change. Otherwise, it will use the default values defined in here. One thing that I want to customize is the service object here, because I want to expose this via a simple load balancer using a different port. So here, first of all, I need to define the service section, service, and then type load balancer. So I can, so let me just copy this here, and then I want to change the port. One for HTTP, one for HTTPS. So yeah, I need to change these because currently on my Kubernetes cluster, there's a reverse proxy running, and that's of course using the same ports here. So I need to change this. Let's just use these two ports. I think that's fine. And then I also want to add my website, not cloning it from a simple repository, but instead I want to still use a config map. So the same stuff that we have done before. Now, how to create such a config map? Actually, it's described here in this object. So we could use this object here. So I think I will just refer to this. So when we go back to the default values, there should be a variable that is called static site from Git from config map. Yeah. So this is of course empty. So I will set this to the name of the config map object. So this should be webcm1. So this config object contains a website. So let's put it in here. And that's basically everything. Now we can deploy this Helm chart with the command using these values. You need to add the values file, of course. So just type in Helm install. You will have to add the Bitnami Helm chart, and then with an F, you define the values file. So let me just check. Helm values is the name, Helm values. And then I want to add this to maybe the same namespace as the other Nginx server. And yeah, let's just hit enter. So this will now start the installation. And you can see here that it's already deployed, so the installation was completed. You can list the installation with a Helm list if you are in that namespace currently. So then you can see on what namespace you have installed what Helm chart and what version it is. So let's get everything. Here's the deployment web that we have done before, and here is that is managed by the Helm chart. There's also the load balancer with the external IP address and the two ports here. the new service object. So everything has been created automatically by the Helm charts with one simple command and a few values that we have defined. And we could basically add or enable any other feature that we need here as well without having to write the complex manifest files ourselves. All right, so let's check if we can also reach the second deployment. Let's first of all return to OrbStack. So here you can see there's a new service created. I can use this here. So let's just open a new window. I think we could use the port 8084. This is using HTTPS, so we have to define HTTPS before that. And yeah, of course, this is not a secure connection because I've not created a trusted TLS certificate. But yeah, as you can see, this is still the website or the web application that I've created using an encrypted HTTPS connection. And that, of course, is, in my opinion, a much better and much simpler way to create Kubernetes deployments. So yeah, honestly, when I'm thinking about it, I think Kompose is a great tool, but I would only use it in a few rare use cases. I would mostly prefer using production-ready Helm charts that have health checks, resource limits, security context, maybe even ingress objects or TLS certificates, and that of course supports easy upgrades with a rollback support only in very few conditions, like if you have your own custom applications or there is no Helm chart existing, but you have a larger Kompose stack that you still want to migrate to Kubernetes manifests. And you're not afraid of jumping into these manifests and maybe tweaking a few things later on. So then I think the tool is actually pretty useful. By the way, if you want to learn how to create your own Helm charts, maybe from Kubernetes manifests, and turn this into something, I could create another video tutorial, so please give this video a like and subscribe to the channel if you want to see more content about this. And of course, thank you so much for watching. Thanks to all the people supporting me on Patreon or as a YouTube member. You guys are really amazing. And I'm gonna catch you in the next video. Take care. Bye bye.